So last week, we've been on 5.5 for a couple of days. Last week, we reviewed several different factoring methods from chapter 4 that we used to do on quadratic equations. We've reviewed pulling out the GCF from quadratic equations. We reviewed solving quadratic equations where the a value is not 1, where the a value is 1. We reviewed factoring by grouping. So we had all these different factoring methods that we reviewed. And why do we review them? To be able to apply them with higher degree polynomials. And how do we do that? We change the higher degree polynomials to look as quadratics in order to apply those factoring methods that we know. So this is a question, I think it's the last question, number 24 from the worksheet. I just want to go over it to explain the concept. See, this is a fourth degree polynomial. You're supposed to always try to pull out a GCF. There is nothing to pull out. There's nothing in common in all three terms. If this were a quadratic trinomial, like if it were x squared minus 21x plus 80, I could then think parenthesis, xx, and think what times what is my c value that if I combine together is my b value of negative 21, right? But it's not a quadratic trinomial. It's a quartic trinomial. So I would want this to look like a quadratic. So the question is, could I change the t to the fourth to look like something squared? And even still, if I'm able to do that, I still need this next value to be exactly the value that's in here. So let me pause right there. Let me go back to last week. In order for you to be able to rewrite a higher degree polynomial into a quadratic, you have to have this degree to be twice as much as the middle term's power. Okay, so if this is a 4 and a 2, green light, you're ready to go. If this is a 5 and a 2, red light, you can't do it. Does that make sense? Okay, so if this is a 6 and this is a 3, go for it. If this is a 10 and this is a 5, go for it. This is a 4 and a 2, that's great. What value belongs in here? T squared. Okay, now do we have a t squared over here? Yes, because t squared is right there. Perfect. All we do is put it in parentheses. And the plus 80 is our c value. So what have I done right here? I changed the look of my quartic. I changed the look of it to now looking like a quadratic. It looks like x squared minus 21x plus 80. And again, the only way you could do this is if your degree is twice as much as the power of the middle term. Okay? So that's a skill that we learned last week. I hope we understand it and we're able to apply it today and from here on out. So now that it looks like a x squared minus 21x plus 80, how do we factor this? We think what times what is 80 that if we combine together is negative 21. You might want to make a list. So what times what is 80? You have 1 times 80, you have 2 times 40, you have 3 doesn't work, 4 times 20, 5 times 16, that's it right there. 5 times 16 is 80, and if you combine it together, it is 21. You guys agree? Yes, but we want it to be a negative 21, so it has to be a negative 5 and a negative 16. Perfect. So anyway, if this were a x squared minus 21x, then we would do this, right? We would put parenthesis, xx. If we had x's, right? X squared and 21x, we'd put xx. But they're not x's, they're t squares. So last week we said substitute, which actually adds on 2 steps to your problem. So let's not substitute. Let's just plug in the value that's instead of the x, which happens to be t squared. Everybody with me? All right, so let's plug in our values of minus 5 and minus 16. And now it's factored. It is equal to 0. So the original equation is equal to 0. It's still equal to 0, but now it's in factored form. So you could continue to factor if possible. Right here you cannot factor. Right here you could factor. So if you wanted to, Grant, Zach, you could change this to a t plus 4, t minus 4 if you wanted to. And then you'd have 3 binomials and you could split all 3 of them, set them each equal to 0. Or you could split them right now and then deal with the t squares. You get rid of the t squares by square rooting. So what do you guys say? Do you want to factor and then split them? Or do you want to split them now and get rid of squares with square roots? Split them now. Okay, now you could do it either way. I'm going to split them now just because he said so. T squared minus 5, that could be equal to 0. T t squared minus 16, that could be equal to 0. So we're going to add 5, add 5. You're going to have t squared equals 5, square root, t equals plus or minus the square root of 5. That's 2 answers. And the other one, plus 16, you're going to have t squared equals 16. You're going to apply a square root, answer t equals plus or minus 4. That's another 2 answers. If I were to graph this quartic polynomial, right, if I get my Desmos app and type in y equals x to the 4th minus 21x squared plus 80, it's going to cross the x-axis how many times? 4 times. It's going to cross at the nice value of 4 and also negative 4, and also at positive 2 point something and negative 2 point something, right? The square root of 5 is an actual decimal value, a crazy decimal, but it's 2 point something. If you do it on the calculator, you'll get those decimal values. Anyways, again, this is a review from last week where we took a higher degree equation, made it look like a quadratic. That way we could apply factoring methods that we learned back in chapter 4 on quadratics. Cool. So last week we also learned about the sum and difference of 2 cubes. So I just want to review sum and difference of 2 cubes. A cubed plus b cubed equals a binomial times a trinomial. And again, the first binomial, doesn't matter which formula you're looking at, the first binomial will be the exact binomial that you started with without the powers. So this one's a plus b. Without the cubes, it says a plus b. Same thing here. The first binomial will be, without the cubes, a minus b. There it is, a minus b. Over here, you have the same trinomial on both. There's only one difference of a sign change. That's it. So if you started with the a plus b, the middle term is going to be a minus ab. If you started with the a minus b, the middle term is going to be the opposite, plus ab. Now, in order for you to apply these formulas, you must set this up, parenthesis cubed plus parenthesis cubed with the minus in between. In order to use the formulas, you have to set this up to identify your a value and your b value. So whatever you have in this parenthesis is going to go into the a's. Whatever you have in this parenthesis is going to go into the b's on all these a's and b's. So I don't know. Let's do this one pretty quickly. Go for it. Let's identify our a and our b. Again, this isn't even part of the formula. This is just to identify a and b. What's our a value that belongs inside of that first parenthesis? X. What's our b value that belongs in the second parenthesis? 2. All right. So now we could set up the binomial times the trinomial. Okay. Now, the binomial is going to be easy. What's a binomial? It's going to be the same binomial without the cubes. What's this binomial without the cubes? X minus 2. That's it, right? Okay, so now that we know our a and b, let's plug it into our formula. We already did the first binomial. Now we have the trinomial. Now, I've always said to use parentheses when you plug it into the trinomial, right? If you have a nice single letter or a nice single number, you don't really need parentheses. You won't make any mistakes, right? So you could just start writing out your answer. What is this first term? It was originally, it was originally a squared. So what's it going to be? X squared. The middle term is ab, but instead of a minus, it's going to be a plus. But you know what? You shouldn't write that. What's going to be in there? What is a times b? It's x times 2. So what do you get? 2x. And then the last term is b squared plus b squared. What's that last term going to be? What's b squared? What's b squared? 4. Okay, maybe you do need parentheses. I try to do this all in our head to make it quicker. But that's it. You factored it. That's the difference of 2 cubes. Now on this one, when we identify the a and the b, you end up with not just a single number or a single letter, you end up with numbers and letters and powers, right? What's the first term, the a value, going to be inside the first parenthesis? What times itself 2 times, or what times itself 3 times gives you an 8c cubed? And how about what times itself 3 times gives you a 27d to the 6th? 3d squared. So right here, you definitely need to use parentheses on your trinomial, all right, so you don't make mistakes. So anyway, now that we identified our a value is 2c and our b value is 3d squared, we can now set up the factored form with the formula binomial times a trinomial. What's the binomial going to be? It's the same binomial that you have here without the cubes. What's it going to be? Yep. And now for the trinomial, please do parentheses. A squared. If it was a plus, what's this middle term going to be? Minus a times b, and then plus b squared. Okay, so please use parentheses if you have more than a single number or more than a single letter. So right here, 2c, use parentheses. 3d squared, use parentheses. All right, so let's plug in our a value of 2c. Plug in our b value of 3d squared. The first binomial stays. The trinomial we need to simplify. What do I end up with? What's 2c times 2c? 4c squared. And how about that middle term? We have a minus. What's 2 times 3? 6. And what's c times d squared? It's exactly that, c times d squared. And last but not least, we have a plus. What is 3d squared times 3d squared? 9d to the 4th. You see how it's important to put parentheses right here? If you didn't put parentheses, you'll probably think that this final part is a 3d to the 4th if you didn't put parentheses. But with the parentheses, it'll help you remember that you need to distribute it to both. So we could use this skill of sum or difference of 2 cubes formula to solve equations. So right here we see x cubed plus something else. The question is this a perfect cube number? What times itself 3 times gives you 216? 15. So we're saying 15 times 15 times 15?
Oh, no, I think it's
8. 8 times 8, 64. 64 times 8.
Oh, no, that's right. 4.
How about the calculator, guys? The question is, could we set this up as something cubed plus something cubed? That way we could identify our a value and our b value. So the first one's obviously x. The second one's what? 6. If you go 6 times 6 is 36, and 36 times 6, it is 216. So now that we know the a and the b, we could set up the binomial times the trinomial equals 0. The binomial is going to be what? It's simply the same binomial without the cubes. So what am I going to write right here without the cubes?
6.
X plus 6. Now, is it essential for me to do parentheses over here? Nah, because there's a simple x and a simple 6. So the first one is simply going to be x squared. I mean, you could do the parentheses if you want, but it's not really necessary. The middle term, if this was a plus, what's the middle term going to be? Minus. And you have AB right here, A times B. So what's x times 6 right in there? 6x. And last but not least, B squared. What is B? It's 6. So what's 6 squared? 36. Again, you didn't have to use parentheses right there, but you have to do it in your head, obviously. If you want to use parentheses, it's probably safer. That's it for the formula. But what that formula does is now gives us something times something equals 0, which means we could split them with the zero product property. X plus 6 could equal 0. So that answer is going to be x equals negative 6 for sure. And the other one is a quadratic trinomial equation. And we could try to factor what times what is 36 that if you combine together is negative 6. It's not going to work. So we don't just give up right there. We know that we could apply a quadratic formula on a quadratic equation. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Yes, we're getting...
You can factor the group in?
You can't factor it, actually. It's not factorable. It's not factorable. Can't pull out a GCF. There's nothing to do. Like, if you start thinking what times what is 36 to give you negative 6, it doesn't work. So let's just do this. Let's not be scared, right? How do you apply a quadratic formula? First, replace the values, the variables, with parentheses. Plug in your a value of 1, your b value of negative 6, and your c value of 36. So the b value is negative 6. The a value is 1. The c value is 36. A value is 1. So how do we begin this thing? You start with your discriminant. What's negative 6 squared? 36. Okay, what's 4 times 1 times 36? Calculator time. Somebody help me out here. That's going to be a negative... Negative what? It's negative 144. Okay. So what we really have is 36 take away 144. What's that? It's 108. Negative 108.
Oh, wait, hold on.
So let's rewrite our quadratic formula. You have a positive 6 plus or minus the square root of, we said it's negative 108 divided by 2. This is our answer. However, the square root of negative 108, that could be simplified. We know that any negative on the inside of a root has to come out as an imaginary. So we have I times the square root of 108, and the 108 could be broken down to a perfect square number. Now, if you don't want to think this through because I let you use the Casio calculators, just type in the square root of 108 and it'll simplify it for you. Who has a Casio calculator right now? So on the calculator, it'll give us 6 square root of 3. So the square root of 108 is really 6 square root of 3. Now that I, this I, you're just going to put it right behind the 6. So 6i square root of 3. So this is really the square root of negative 108. So let's now replace it. So we have x equals 6 plus or minus 6i square root of 3, all divided by 2. And we've learned in the past that when you have something plus or minus something, all divided by 2, you could take that divisor of 2 and split them to each of the terms. Or you could think of it as reducing, right? If you reduce each of these by 2, reduce by 2, reduce by 2, reduce by 2, your answer will be x equals 3 plus or minus 3i square root of 3. That's your final answer. So you do have 3 answers to this cubic equation. That makes total sense. One of them is real. The other 2 are not. The other 2 are complex. They're imaginary. So if I were to tell you how many times will this cubic function cross the x-axis, what would you say? Only once. Where would it be? At the location, the x-intercept of negative 6. So I noticed that we haven't really applied factoring by grouping on solving equations. Jot this one down. This is from the book assignment that we're going to be doing, page 67, number 67 on page 346. So we're always trying to factor to be able to get multiplication, to be able to split them and solve with zero product property. You're always supposed to try to pull out a GCF, and there is no GCF in all 4 terms. But we do notice that there's a GCF in the first 2, which means that we could probably factor by grouping if we get a common binomial after factoring each group. So let's do step 1 of splitting it into 2 groups. And then after that, just leave space between the first 2 terms and the second 2 terms. After that, let's factor out what we can from the first group. What's the GCF in the first group? Not just 4. 4x squared. All right, what would be left on the inside? An x squared minus 1. Okay. Now over here, there's nothing to pull out. So, but you know what? This x squared is positive. This one's negative. So let's pull out a negative 1. And hopefully we end up with that same binomial. And we do. We end up with a positive x squared with a minus 1. So as you can see, this is a common binomial in the first group, common binomial in the second group. We're going to take this common binomial, pull them out of both groups and put it out here in the front. So we have that x squared minus 1, that common binomial out in the front, some exaggerated parentheses, and what do we have left over in here? We have a 4x squared and a minus 1. So what we have so far, guys, is x squared minus 1 times 4x squared minus 1. And this is now this. It's still equal to 0, so it still needs to be equal to 0 here. So at this point, we could do what we did last time, split them and solve. And of course, we're going to have to deal with the square root. Or let me show a different way. You could continue factoring. What do I mean by continue factoring? That x squared minus 1, that's technically a difference of two squares, right? It's like if you had a perfect square term here and perfect square term there, there's a minus sign. You could set this up, and one's going to be plus, one's going to be minus. What's the square root of x squared? Come on, guys. X. And what's the square root of 1? So you just have an x plus 1, x minus 1. That's pretty easy to do, right? And how about the other one? Same deal. It is a difference of two perfect square terms. So what's the square root of 4x squared? 2x. What's the square root of 1? And we said one has to be a plus, one has to be a minus. So we have completely factored this time. You didn't have to do it. You could have split it and then dealt with the squares by doing square roots. But right here, I just wanted to show you another way of completely factoring and then splitting everything, set it each equal to 0. So that x plus 1 is equal to 0. The x minus 1 is also equal to 0. The 2x plus 1 is also equal to 0. And the 2x minus 1 is also equal to 0. This all becomes 4 different, very basic 1 or 2 step equations. Your final answers will be x equals negative 1, x equals positive 1. If you do the work correctly, you'll get x equals negative 1/2, and also x equals positive 1/2. Those are 4 real answers. Those are the actual locations of where this quartic degree or quartic equation would cross the x-axis if I were to graph it. So just to review, the leading coefficient is positive, and it's an even degree polynomial. If I were to graph it, the end behavior would be in quadrant 1 and quadrant 2. It would cross at negative 1, positive 1, 1/2, and negative 1/2. And that's about it. Ladies and gentlemen, our homework assignment is going to be from page 346. Let's actually skip 1 and 2. Those are factoring by grouping, and they're huge. So let's skip those. I didn't see that on the final coming up. So let's just do 20, 21, 12, 13, 34, 35, and 68. And once again, the answers are on the wall. They'll be posted to Edmodo, the solutions. And whatever solutions are missing, we probably did them on this video in this class.